Hello guys, today we are doing 2021 for AMC 12A, problem 7. Let's get started. The school has 100 students and 5 teachers. In the first period, each student is taking one class, and each teacher is teaching one class. The enrollment in the class are 50, 20, 25, 5. Let T be the average value obtained if a teacher is picked at random, and the number of students in their class is noted. Let S be the average value obtained if a student was picked at random, and the number of students in their class, including the student, is noted. What is T minus S? Okay. So first of all, I think it asks T minus S. So these are two separate sub questions. We can just calculate that one by one. You see, I also draw a graph. Let's see, we have teacher, have student, I have 5 teachers and 100 students, and then we have, for example, like 5 classroom, right? 50 student, 1 teacher, 50 student, 20 student, 1 teacher, 20 student, 1 teacher, 5 student, 1 teacher, 5 student, 1 teacher, right? So our first quantity is T. What is T? So we randomly pick a teacher. Okay, so 1, 2, 3, 4, 5. Randomly pick a teacher. What is the average value? Average value of what? Average value of the number of students in their class, right? So we randomly pick a teacher, right? So that means what we have is we must have 1/5, 1/5, 1/5, 1/5, and 1/5 multiplied by what? It's multiplied by the number of students in their class. So we have 5 class, assuming you pick a teacher at random, right? And this 5 comes from 5 classes, right? Assuming you pick a teacher random, right? So what is the chance it get allocated to this room? 1/5. And what's the number of students here is 50. And similarly, what if it get picked in this room? Then it is 20, right? So we do the same thing for the other class, and then because we are doing average, or in a more formal way is doing expectation in probability. So we sum them up. What we get is 100 divided by 5, which is equals to 20. Okay, now let's move on to S. Right, so for S, be the average value obtained if a student was picked at random and the number of students in their class, including the student, is noted. So if we randomly pick a student, right? Think about it in this way. if we randomly pick a student. All right. What is the chance that it falls into, let's redraw it's 50, uh, 20, 20, 5, 5. So we can ignore teacher. So if we randomly choose a student, what is the probability of it falls into this class? It's I think it's 50 over 100. What is 100? 100 comes from the sum of these numbers. So it has the probability of 50 over 100 to get the number of students uh, with 50 students. And similarly, if you randomly pick a student, and what is the probability it falls into the second class, it is 20 over 100 and multiply by 20, and then we do the same thing over 100. 5 over 100 multiply 5, 5 over 100, 5. So this one should be equal to 2,500 plus 400 and plus 400 and plus 25 plus 25 over 100, which is 25 plus 8 plus 0.5. It is equal to 33.5. So if you if you use 33.5 minus by 20, and you get answer D. I think um, I think this problem needs some thinking. It is not trivial. As I just mentioned, we need to um, understand the problem more deeply, or understand probability more deeply. So it is a matter of probability versus expectation. Um, so if you look at the quantity defined as here, and the average value, right? If a teacher is picked and the value of number of students, right? This is very important because how can we understand this sentence? From this sentence, we know two things. So the value is not comes from the teachers. Actually, the value always comes from the number of students, right? So that means this is actually is our um, random variable. And then the values or the value set, right, is actually equals to 50, 20, 20, and 5 and 5. So we know that our answers by the end of the day, you see here, no matter that is this one or this one, right? It must have the patterns like this. Uh, it must have a pattern of P1 equals to 50 plus P2 multiplied by 20 by P3 multiplied by 20 plus P4 multiplied by 5 plus P5 multiplied by 5. Why? Because because the question is asking the expectation or the average. So in statistics or probability, average is just expectation. So what is the formula for expectation? It is actually equals to the sum of 1 equals to n and the probability of I and times the value of the random variables, right? So the but what is our variables? The variables is actually the number of students, right? So we know that the values must be 50, 20, 25, and 5. And they are multiplied, they will be multiplied by probability. And where does the probability comes from? The probability comes from what is the probability um, that we choose this class, right? What is the probability we choose the number of 50? All right, so that will be the trick. So the probability according to the question actually comes from here. Whether it is a teacher picks or whether it is student picks. So this part will help us to determine the probability. This is very, very important. So the probability to choose a class with a size 50 or a size of 20 depend on how the probability is given or is created. And that comes from the differences between T and S. So for T, the probability is driven by the teacher. However, since each of the class, no matter that is 50 or 20, we always have one teacher. So actually the probability distribution, if we for a teacher, P1, so the probability distribution of P1 to P5 is actually equals to 1 plus 1 plus 1 plus 1 plus 1 plus 1 over 1, and blah, 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 the same thing. So that is the trick. So that is the central part of our problem. So to determine the probability. And then with the same logic, if we go back to student, then what? The probability we choose the 50 class have to the probability of choosing this class is driven by the student. So that is why the probability distribution in this case should not be 1 1 1 1, should just be 50 plus 20 plus 20 plus 5 plus 5 over 50. And then the next one is um, 50 plus 20 plus 20 plus 5 plus 5 over 20, and etc. As you can see, what is the difference between T and S? So they have the same um, random variable values. So the values are the same, but the probability distribution are different. So that is the central part of this question. And then of course we can choose the answer D. I hope I can explain this problem clearly, because it is a little bit tricky and it is not that straightforward if you think it deeply. Yeah, that's all I want to share today. Thanks for watching.